Okay, this is a week 14 calculation of a weak acid. Weak acid is typically can be represented by Ka constant is very small, and this has we can use this small constant to approximate and simplify our calculation. So let's start to understand what our weak acid is. This is a compound. If I draw the Lewis structure, it is like this, and this is a formic acid. Okay, so let's write the chemical equation first to represent the Ka value. So this is a C. I prefer to actually write this way. That's a formic acid, and the water, and they produce hydronium, H3O plus. That's make it acid, and then their conjugate base, which is HCO2 minus ion. So initial change, right? And an equilibrium. That's an ice calculation table. And then what is our initial value? So this is an initial concentration of formic acid. Formic acid. Okay, so this is a 0.350 molar concentration. And we're going to assume that there is a small change because it's a weak dissociation. Small amount of change will be, I guess, decomposed or dissociated, and they produce X molar concentration amount of H plus and also X amount of conjugate formic acid ion. And then if you add them together, you will see 0.350 minus X and X and X. Okay, and then note that this is a Ka value is very, very small. Okay, that's a weak acid. And so we are going to write a definition first, which is HCO2H, formic acid concentration, and H3O plus, and HCO2 minus. So now this is a concentration at equilibrium concentration, right? So therefore, that's the one we are going to write, 0.350 minus X. And this is an X squared. And this one is 1.7, 10 to the minus 4. Okay, so this is our job now, trying to solve this quadratic equation. And you can continue to solve this quadratic equation, but in the this IC problem, when you have this Ka value is very small, there is a certain approximation can be done, which is we know that 0.350 is certainly much bigger than small constant a, x, so therefore 0.350 minus x is approximate to be the same as 0.350. Okay, so using this approximation, okay, so this is an approximation. We can simplify this equation now. X squared 0.350 1.7 10 to the minus 4. So which is very simple now, because now x squared is 0.350 multiplied by 1.7 multiplied by 10 to the minus 4. And all I need to do is do the square root on both sides, right? So therefore, what I have now, x, which is a concentration, is square root 0.350, 1.7, 10 to the minus 2. And that's the going to be the value 1, 2, 0.350 0.77 10 to the minus 2 molar concentration. Okay, and what was the question now is what is the concentration of this value, right? So this is actually same as if we find out in the equation of up there, which is I'm going to circle it, right? So this is an X, and that can be a concentration of H plus, so therefore that's an H3O plus. Also, okay, so that's the first question, and also the pH, which is a minus log 10 H3O plus. So you plug those values in, and you will find out plus 2.11. That's the pH value from the addition of this formic acid. Okay, so that's a answer for this question. So please note that this is a really important understanding how the approximation, particularly this one shown up here, when you see the value minus x and x is very small, that can be approximate to be this value. Okay, thank you for your attention.